Okay, good morning. If you don't mind, let us go through the problems in the quiz and to see if you have problems there. And then I remember there was also one homework assignment that I haven't done. If we have time, we go through both of them today, okay? But let us do this one first. So the first question, if f of x is this function, you are supposed to calculate f double prime of 0, okay? And of course, I also, if you just randomly write the answer here, I will not give you the points. You have to read the instructions. Okay. So what is the function here? The function is, so the function f of x is equal to, let me see if I'm recording, yes. F of x is equal to 4x squared plus 3e to the power of minus 3x. The goal is to calculate f double prime at 0. Yes? Okay, so what we have, very simple, you know how to do it. Yes, I have to take the derivative 2 times. After the second derivative is found, I am supposed to replace the x in the second derivative with 0 and then calculate the number. But there is one formula, 2 formulas you need, yes? So x to power a prime is what? A x to power a minus 1. And the other formula that you need is e to power kx prime is k goes down and the function repeats itself. So these are the formulas. So what can I do now? I can calculate the derivative of the function f. This becomes 8x. But this 3 is a constant, so what should I do? This minus 3 is playing the role of that k. So that k goes down, minus 3 times 3 is minus 9, but the function repeats itself. So this is the first derivative. The second derivative is what? The derivative of 8x is simply 8. And the same story, minus 3 goes down, multiplied by minus 9, it becomes plus 27, but the function repeats itself. This is my second derivative. Yes? Okay, and then what happens? My question mark is to calculate f double prime of 0. So this means every x should be replaced by 0 now. There is no x here. And this becomes e to power minus 3 times 0. But what is this number? Minus 3 times 0 is 0. E to power 0 is 1. So the answer becomes 8 plus 27. So the answer becomes 30. As simple as that. So the answer to the first question is 35. Yes? Do you have any questions? Okay. So let us go to the next problem. Okay, so consider the function f of x equals to x cubed minus x squared. F of x equals to x cubed minus x squared minus x plus 2. The sum of maximum and minimum values of this function on this interval is equal to what? Okay, and I told you that in this chapter there are several algorithms that are very similar, but you have to know which one to use when. Yes, this I told you several times that if the interval is given, the algorithm is not the algorithm of that long table. It is not working. So if you just use them wrongly, you will not get the points. So do you remember which algorithm is that? So let me go to the board. So f of x is equal to x to the power of 3 minus x to the power of 2 and then minus x plus 2. The interval given to you is from 0 to 2. You are supposed to find the maximum and the sum. What you know what the sum is. You find the numbers and add them up. That number is called the sum. So I want to find the sum of the maximum and minimum values of this function on this interval. So what should I do? You remember the algorithm? The first thing you have to do is to calculate the derivative, which is 3x squared minus 2x minus 1. And then what you are supposed to do, you are supposed to put it equal to 0. Okay, and that is up to you how you solve the problem here. You can use PQ or ABC formula. Okay, so most of you are more familiar with PQ formula, so if you don't mind, let me use that. But if you want to use PQ formula, you have to be careful. You have to divide this by 3 first. So if you divide by 3, what happens? It becomes x squared minus 2/3 x minus 1/3 equals to 0. And then you find the formula, PQ formula in the formula sheet. I have it in my memory, so it is minus p over 2 plus or minus the square root of this number to power 2 is p over 2 squared. I don't need to put the minus sign because it doesn't matter. And then minus q. Okay, and then you find the number. So what is playing the role of p? This is your p, and this is your q. Let me have this color with me. Okay, so what happens? It becomes minus p divided by 2. P itself is minus. When you put a minus, it becomes positive. So it is positive 2 over 3. But then you are supposed to divide it by 2. So instead of 2 over 3, you will have only 1 over 3. Plus or minus the square root of this number to power 2 is 1 over 9. Minus q itself is minus, so it becomes minus 1 over 3, so it becomes plus 1 over 3. And then you have to simplify this. That's why I don't like PQ formula, because you have to work with fractions sometimes. But it doesn't matter if you can do it. So between these two, I can take the common denominator, so 9 to 9 one time, so that is 1, remember it in your head. 9 to 3 3 times, so it becomes 3. 3 plus 1 is 4. So 1 over 9 plus 1 over 3 is 4 over 9. If you are using PQ formula and the calculator is not allowed, this level of calculation is assumed that you can do. Okay? But this is very simple now. It's 1 over 3 plus or minus a square root of 4 over 9 is 2/3. So I get two answers. One answer is 1 over 3 plus 2 over 3, which is 3 over 3. But 3 over 3 is what? 1. The other answer is what? 1 over 3 minus 2 over 3, which is minus 1 over 3. Okay? And I intentionally designed the question in that way because I want you to see if you can differentiate the algorithms. Many of you started using this one as well because you wanted to draw the table. Yes, if you want to draw the table for finding local maximum and local minimum, you have to consider this one. But here you don't need to consider this one because my goal is different. I want to find maximum and minimum, absolute maximum and absolute minimum. So whenever I found the numbers here, I have to check if they are within my interval or not. And then you immediately see that this is not within your interval, because it is negative. My interval starts from 0 up to 2. So the only answer from this is just 1. Okay? But do you remember what was the rest of the algorithm? You are supposed to do what? Yes? Yes, you have to calculate f, not f prime. F at the acceptable number there, but also at the end points. And the maximum number is the maximum, the minimum number is the minimum. So there is no table involved. Okay? So what I should do, I will calculate f of 1. That is also simple. So I go here and replace every x with 1. Okay, so this becomes 1 to power 3 minus 1 to power 2 minus 1 plus 2. So it becomes 1 minus 1 minus 1 plus 2. Yes? And then this one, and so it becomes 1 finally. I put this in a box because that becomes important. But I have to calculate f of 0. And yes?
Why is there no table involved?
No, because this is a different algorithm.
I see.
That table is for local maximum and local minimum. This is not local maximum, it's local minimum. So you have to write f of 0. F of 0 is 0 to power 3 minus 0 to power 2 minus 0 plus 2. So the answer becomes 2. And then finally f of 2, you have to replace x with 2. So 2 to power 3 minus 2 to power 2 minus 2 plus 2. Yes? So then it becomes 8 minus 4, and these two and that two are gone, so it becomes 4. Okay, now you see between these three numbers, the maximum is 4, the minimum is 1. So maximum, max of f is 4, min of f is 1. But the question mark is the sum of these numbers. So it becomes 5. So it is extremely important to don't mix up these algorithms. So I told you that whenever maximum and minimum on an interval is given, it has nothing to do with that long table. This is the algorithm we use. I think majority of you missed that point. You try to use the table. The table is useful for local extreme points, not the extreme points. Okay, so let us see now the next question. Let f be a function whose derivative is this function. F prime of x is given. X squared plus 5x minus 6. The point A with x coordinate 1 and y coordinate f of 1, whatever f is for this function a saddle point, an ordinary point, a local minimum point, a local maximum. Okay? So think a little bit so that I can see. I adjust the camera here. Okay, so what is the function now? You see the function is not given to you. F prime of x is given. F prime of x is given to be what? X squared plus 5x minus 6. And the point A, whose x coordinate is 1 and its y coordinate is f of 1, which I don't know because I don't know f, I know f prime. X coordinate is A. I want to see that if I find this point and I have access to the function f itself, for the function f, what type of point is this point? So I have to choose one of those options there, yes? Okay, so how should I do it? It's a very simple question, by the way. So what is the answer? I put 1 here to see what happens. Okay, so f prime of 1 is what? Is 1 to power 2 plus 5 times 1 minus 6, which is 1 plus 5 minus 6, 0. Okay? So what you get? You get f prime of 1 is 0. So this is something you have to know. If the derivative is 0, that point is a candidate for a local max, a local mean, or a terrace point. So this is not ordinary point. Ordinary point should be ruled out from the options right away because the derivative is 0. If the derivative is 0, either that is a local max, a local mean, or a terrace point. But how should I know which one is which? There are two algorithms for local maximum, minimum, and terrace point. What are those algorithms? First derivative test, the long table method. Second derivative test. First derivative test, I will not do it if I have to do it. So I will usually use it, especially Ma3c, if I am not forced to choose. I use usually f double prime, the second derivative test. The second derivative test, you have to remember the content because it is not in the formula sheet. What is the second derivative test? I take the second derivative. Second derivative is easy. One derivative is done by the designer of the question. So you want to find one more derivative. So what's the answer? It's 2x plus 5. You have your candidate. 1 is the candidate for local extreme point. So I take that number and put it here to see if the second derivative turns out to be positive or negative. If I am unlucky, it turns out to be 0, then I am in trouble. But if it is not 0, I can conclude. So let us calculate. I replace x with 1. So it becomes 2 times 1 plus 5. What is the answer? 7. 7 is positive. But then you have to remember, there is nothing you can do at this point. So if the second derivative is positive and the first derivative is 0, what type of point is this point? A local minimum. So this point is a local minimum. You see, these are E-level questions, so these are very simple. So, but these E-level questions is still you have to know the content. Any questions here? So, the derivative was given, a number was also given. I put that number in my derivative. I see that, oh, the first derivative is 0. If you have learned the lesson, you see that at this point, at this stage, this point is a candidate for a local mean, for a local max, or a terrace point. And then I need the second derivative because I want to use, for example, the second derivative test. The first derivative is done by the designer of the question, me in this case, and then the second derivative is what you need to do. So you just need to take one more derivative of this one and put that number in. It turns out to be positive. If it is positive, that point is minimum. If it is negative, that point is maximum. And if unfortunately it turns out to be 0, it means that the second derivative is not capable of answering you the question. You have to go back to the first derivative test, which in this case it was not. We were able to find the answer. Okay, so now let us go to the next problem. The next problem, consider this function. The local extreme point of this function is a local what? And its value is this one. Because you know that when I say local extreme, it could be local max, it could be local mean. I am asking you what type of point is that? Is it local mean or max? If you think it is minimum, you type minimum. If it is maximum, you type maximum. And its value is equal to what? So that's what I want to do. Is that right? Okay, so let me see. Okay, so what was the question? F of x is equal to what? X to 3x to power 4. And then I have minus 8x to power 3. And then plus 6x squared minus 12. Okay, I want to see what type of extreme point, local extreme point does this function have, and what is its value. Okay, how many algorithms potentially I have? Let us review, because when I read, you are sometimes using the algorithms randomly. Okay, for local extreme points and terrace points, we have only the first derivative test. Yes, but for local extreme points, we have two tests, the first derivative test and the second derivative test. Okay, so what should I do first? I have to do the derivative. So f prime of x is equal to what? 12x cubed minus 24x squared plus 12x. You agree? And the second step is to do what? To put this equal to 0. This is a C-level question, okay? So f prime of x equals to 0. But this is, we have these type of questions during the lesson. If the degree is higher, there is only one hope for you to be able to factorize this. But the factorization is extremely simple in this case. So 12x cubed minus 24x squared plus 12x equals to 0. What is the factorization? You see every one of them is divisible by 12, and every one of them is also divisible by x. So this motivates me to factor 12 and x out. So from here, what is left? X squared. From here, minus 2x. From there, just plus 1. And then, of course, I don't think it is hard for you to see this is also a pattern. If you don't realize that, then you have to use PQ or ABC formula to solve it. But can you see this pattern? It is x minus 1 to power, yes, equals to 0. So what are the answers I get? 12 cannot be 0 because the product is 0. If the product is supposed to be 0, at least one of them should be 0. But 12 cannot be 0 because it is 12. This can be 0, this can be 0. If this one is 0, I have one answer. If this one is 0, I have the answer x equals to 1. So far, if I ask you what are these numbers, I'm just reviewing things. These are not part of the solution. I'm reviewing things so that you can remember. What are these? These are just candidates for local max, local mean, or terrace point. Okay? Might be one of them is a terrace, the other one is a max, one of them is max, one of them is mean. We have to realize which one is which because we have to write this there. From now on, I will have two tests, okay? Either I decide to go for the second derivative test or I decide to go for the first derivative test. But remember, first derivative test is longer, but it is always able to answer all sorts of questions. But second derivative test is not always capable of answering all the questions we want, unless the second derivative is either positive or negative. I don't know which one you prefer to do, because if you want to do another derivative, don't do it here, because you haven't studied the product. Go back here and do the second derivative test. Okay, so let us do for the time being, because I myself always prefer to do the second derivative test, but let us see how it works. If I do the second derivative test here, so let me write it with a different color. The second derivative will be what? It will be 36x squared minus what? 48x and then plus 12. Yes? Okay, then what I can do, I can calculate f double prime of 0. What do I get? It gives me 0, 0, 12, which is positive. So this means x equals to 0 corresponds to what? To a local minimum. Okay, but then let me calculate f double prime of 1. What is f double prime of 1? I have to replace x with 1. This becomes 36 minus 48 plus 12, which becomes 0. So this means that the second derivative test is not capable of answering what type of point is 1. Okay? Of course, most of the time in Ma3c lesson, it is a terrace point. But, okay, so this means that regarding this point, this test is not conclusive. So this is why I have to use the first derivative test if it is not a multiple choice question. Because if you don't have access to the... Now you can answer the question. What is the question? Because you know that according to the way that I have designed the question, this should be a local minimum. Okay? And if I want to find the value, this is the minimizer. I take it from here and put it in my function. This is 0, this is 0, this is 0, so its value is minus 12. Okay? But I don't know anything about the second one. So it is better here, because one of them is not answered, to do the first derivative test. Okay? For the first derivative test, you don't need to fill up all the things, because you need to answer just the question. So this is the x row, this is the f prime row, and this is the f row. The numbers I got are 0 and 1. Of course, these are 0 here. Yes? If you want to, you can write these numbers. If I put 0 in my function, the answer is minus 12. If I put 1 in my function, what will happen? It becomes minus 11. Am I right? So 3 minus 8 minus 5, 1 minus 11. Yes. Okay. And now I need to find the sign here. And the sign is also very simple. You see, this is your derivative. If x is less than 0, you can choose a random number, but it is not needed here because 12 is positive. If you choose a random number here, that number is negative. So positive, negative, but this power of 2 is always positive, so the product becomes negative. So this is negative. If I choose a number between 0 and 1, if you want to, you can choose randomly, for example, 0.5 and put it here to see what happens. But this is very simple, because if I choose a number here, which is positive, 12 is positive, x becomes positive, and because of the even power, this is always positive, so when I multiply them, it becomes positive. I really don't need to calculate anything. And if I choose a number after 1, you can do it, but this is even simpler. If I choose a number after 1, that number is positive, 12 is positive, that number is positive, and then this number to power 2 is positive. So when you multiply, it is positive. So then what happens? This is decreasing, this is increasing, and that is also increasing. So you see that this point is indeed what type of point? A terrace. And this point is a local minimum. Yes? So the answer to the question is that you need to type minimum, or I don't know, min, whatever, because I also correct it manually. This should be in the, and then that value is minus 12 should be typed in the second box. So one box should be this and the other box should be this. But of course, if you just type these things without solutions, you will get 0 points. Yes. Yes, please.
Could you please remind me why x minus 1 to the power of 2 will always be positive?
Yeah, because even powers are positive. Whatever this number is, when you raise it to power 2, it's positive.
Minus 10 minus.
Yes. Okay. Any questions? Let us go to the next problem. Consider the following figure. The maximum volume for the blue cylinder is equal to, because typing pi was not easy, might be you don't know how to type it, so this I put the type pi here myself so that you can just put the number here. Okay, so most of you didn't solve this problem. You were doing something strange, but I hope that at least you understand that this problem is an optimization problem. Apparently, none of you remembered that this is an optimization problem. You try to approximate something like this. It's an optimization problem. How many cylinders I can fit into this? How many blue cylinders I can imagine within this cone? Infinitely many. Some of them are narrow and taller. Some of them are shorter and flatter. Among all those cylinders, I want to find what is the maximum possible volume for the cylinder. So it means this is an optimization problem. Yes? Yes? So we want to understand this problem. Okay, so let us do that here on the board. Okay, so this is a thing that you have here. So for example, this is my cone, and this is the cylinder. Let me change my color. So this is the cylinder, that one of those infinitely many possible cylinders, yes? Okay, so this is, so from here to here is given 12. So what is the radius of the cone then? The radius of the cone is what? 6. And the height of the cone is 12. Okay, so let me write it a little bit properly. So this is 6, all of them in centimeters, yes? And what is wanted? Okay, we want to find the maximum possible volume of this cylinder. I told you that whenever you read an optimization problem, first of all, you have to know it's an optimization problem. Because why this is an optimization problem? Because I am maximizing something. What is that something? That is important. That is the target function. So what is the target function here? Is the volume of the cylinder. Then you have to go to the formula sheet and read the volume of the cylinder from the formula sheet. If you do that, it becomes V equals to pi r squared h. This is the formula for the volume of the cylinder, but be careful. R is this radius, from here to here is R. Yes? It's a very bad picture, but this is R, and from here to here is H. Is that right?
Yes.
So this is the R and H. Okay, so first of all, you recognize what the target function is. You realize that is the volume of the cylinder. Then you find the formula from the formula sheet, and the problem usually is you have more than one variable in your target function. Yes, pi is a constant, but R and H are two variables. Why? Because this is one of those cylinders. I can make it narrower and taller. So this means that R and H are changing simultaneously. Yes? This is not good because I need to have function of one variable. So then it means that that is the hard part of optimization problems. You need to find a relation between these two variables so that you can write this as a function of one variable. The creative part of optimization problems are usually coming here. And there is no standard way to understand it. Sometimes it is algebra, sometimes it is geometry. So you have to know a lot of things to do this. So when I want to do this, I don't know how many of you remember what to do. So for example, let us have a cross section of what we have now here. So if I have a cross section, let me exaggerate a little bit. Okay, so what happens? Something like this will happen, yes? By the way, I don't need the other part, so let me just cross section on the right side. That is enough. Okay, and then this part will be here, for example. Okay, but from here to here is how much? Is 6 centimeters. I'm exaggerating so that you can see a little bit better. And from here to here is how much? No, is R. Is the radius of the cylinder. I don't know the radius of the cylinder because cylinder is not a fixed one. So from here to here is R. Okay, and then if you have this cross section, you see, from here to here is the height of the cone. So from here to here, what is that? It is 12. Okay, and from this point to some point there, for example, is how much? It's h. This is what you have. Okay? So then I don't know if you have seen the previous lessons in Ma3c, for example. This is a famous theorem, yes? Have you seen top triangle theorem or something like that? Yes, if you have something like this, and if you draw a parallel line to this, okay? For example, if this is x, this is y, this is z, this is t, this is m, this is n. If you know that this line and that line are parallel, what can you write? Have you seen similarity or something like this before? Okay, so what you can write x from here to here divided by the whole length, which is x plus y, equals to z over the whole length, z plus t, equals to n over n. This is a famous Ma3c problem, yes, a theorem. Okay, so you use this one here. So how can you do that? For example, I draw this line, okay, and by the way, I have to be a little bit careful, you know, because this length and that length are the same. So let me do it like this. Yeah, this is better. This is R. Okay, can you tell me how can I use this theorem that I told you? Because if this is R, you see this is one part of the cylinder, that is also R. My goal is to find a relation between R and H in this picture. So what can I write? For example, if I ask you, can I know something about this? You say the whole thing is 12. This part is H. So what is this part? Is 12 minus H. And then use this theorem. This part to the whole part, 12 minus H divided by 12 is equal to this R divided by 6. So that was the hard part of this question. Okay? So any questions regarding this? Can you feel that? I am just taking this part of this picture and making it bigger here that you see. This R and that R up there should be the same. So that is half of my cylinder, half of the cross section of my cylinder. And of course, this is parallel to this one. Yes? So I can use this theorem. I can say that this length is 12 minus h divided by the whole length, which is 12, is equal to this length, which is r, divided by the whole length, which is 6. It is also equal to this one, to the whole thing, but I don't have any information regarding those, and I don't need them because I need this only. Okay, let me simplify this a little bit. For example, I multiply everything by 12 to get rid of fractions. So this becomes 12 minus h. The right-hand side, 12 and 6 are simplified 2 times, so it becomes 2r. Okay? And then I hope that you see that if I move h to the other side and 2r to the left, it becomes 12 minus 2r is equal to h. And then I will take it and put it here. And then my function becomes a function of one single variable. Yes? So this becomes v equals to pi r squared, but instead of h, I put 12 minus 2r. Now I can safely write it as a function of r only. Yes? And then I do the same. I multiply this in, so it becomes 12 pi r squared. I multiply this in, it becomes minus 2 pi r cubed. And then I take the derivative because I want to find the maximum. So v prime of r is equal to what? 24 pi r minus 6 pi r squared. Then I put the derivative equal to 0. Then what happens? 24 pi r minus 6 pi r squared is equal to 0. And I want to solve the equation. I factor 6 pi r out. From here 4 is left. From here only r is left. There are two options. Either r is equal to 0 or r is equal to 4. Of course, r equal to 0 is not acceptable. I cannot, if I make r equal to 0, it means that I will have a line from here to here. That is not a cylinder. Okay, so definitely r equals to 4 should be acceptable. But if this is national exam, you have to really motivate that this is a maximizer, not a minimizer. Because when you put the derivative equal to 0, it might be a maximizer or a minimizer. So that's also simple. So that is enough in the national exam. So you take the second derivative. This becomes 24 pi. This becomes minus 12 pi r. And then you put the second, you put that number here, which is 4. This is 24 pi minus 48 pi, which is negative. So yes, if the second derivative is negative, the first derivative is positive, that's a maximizer. So indeed, yes, r is 4. But what is wanted in the problem? In the problem, the maximum volume is wanted. So you have to calculate the maximum volume. For the volume, you need r, you need h. R is 4. But what is h? I put it here. Yes? If I ask you what h is, what is h? 12 minus 2 times 4, which is also 4. And then I calculate V maximum. So V maximum is what? Is pi multiplied by r to power 2 multiplied by h, which is also 4. 4 to power 2, 16 times 4, 64. So it becomes 64 pi cubic centimeters. I have already typed pi myself, so the number that you have to type there is 64. So you have to type 64 here. Yes? Okay, so I want you to know, of course I told you that in the national exam, usually harder questions, they design a little bit hard question in optimization, but that is not end of the life because at most you lose 3 points if you really don't do anything with the problem. Okay. So, any questions regarding this? No? Okay. So, let us now go to the next problem. So, this one is also A-level question here. Some of you consider this one. I don't know how should I mention. You see the following figure portrays part of the graph. I have written it in italic and a different color. So this is not the graph of the function itself. It's yes?
Sorry, I have one question.
Yes?
You get 2 points. Where do you receive the first point?
The first point is if you find the function in this form completely correct. Yes. Yeah. Because, because writing this is useless. If you just write this one problem, you get some points for this one only. But if someone writes this, probably they will not stop here because it is easy to go forward. And by the way, if you go forward, the rest of it is simple because the only creativity that you need is just writing this. Yes? Okay, so this is important. If you forget when you come in the exam, if you even see something similar, for you it doesn't matter. That is the first time you see it because nothing is in your memory. That's what I'm saying. And then you will fall into the same trap again. So if I change this, for example, from a cone to a sphere, for you, it is completely everything from scratch, if you don't have anything in your memory. So when we solve problems, the idea is to improve your problem-solving skills. What does it mean? If you want to be skillful in some task, it means that you are really using, if you're a good driver, you don't think about every time how to drive, or how should I change the gears or something. It comes automatically. If your memory is gone, every time you sit down in a car, it's as if it's the first time you're sitting in a car. Okay, so you have to really be careful about memory role. Okay, so let us solve this problem. This is an A-level question, but it is not very hard, okay? First of all, be careful. In the national exam, you will not have italic letters, you will not have colored letters. All of them are plain black. So, but here I am drawing your attention, but many of you assume that this is the graph itself, and they say this is a minimum, this is a minimum, so, and this is a maximum. Okay? And probably they are saying that this is an inflection point if you are a little bit better, and this is another inflection point. But you are talking as if this is the graph of f, but this is the graph of f prime. And we had these problems during the lesson, if you haven't forgotten. Anyway, it is hard for me. So I want to understand that in each of the following boxes, type an integer 0, 1, 2, 3, 4, or 4, so that the statement becomes a true statement. You see on this interval from 0 to 5 here, f has or have local maximum point or points. How many? 0, 1, 2, 3, something like that. I want to type these numbers appropriately here. Okay, so if you don't mind, let me clean the board and somehow sketch it here, because it would be hard to explain here. So this is the picture that I have, more or less. I have this, it comes and touches this graph, goes up to some point and comes and touches the graph and goes up to here. That's enough. We don't need to do things very precisely. So be careful. This is f prime. Y equals to f prime. Okay, so let me give some names here. Let me call this one point A. Yes? Because you already probably know that these points are important. Okay? Everyone realized that these points are important, so that is at least good. Okay? But be careful. If I ask the question for f prime, what type of point is this? Local minimum. For f prime. What type of point is this? Local maximum for f prime. What type of point? Local minimum for f prime. Are there inflection points for f prime? We can guess. Yes, inflection point, you see, approximately here. Because before that, it was concave up, and after that, it is concave down. And there is another inflection point around here. Before that, it is concave down, and after that, it's concave up. But all these things that I told you is for f prime, not f. But the question is asking about f, which we don't have the graph here. Okay, so it means that be careful. For this one, can you tell me what is f prime of A? What is f prime of A? This is f prime, and it touches the x-axis. So this is a null stelle. But null stelle for what? For f prime. Yes? Do you know the null stelle? If you have a function, whenever it cuts the x-axis, that number is the null stelle for the function whose graph you see. So this is a null stelle not for f, for the function whose graph you see, which is f prime. When you say A is a null stelle for this, what does it mean? It means f prime of A is equal to what? 0. Okay? This is the derivative 0. So it means that this A for the original function is a candidate for local max, local mean, or a terrace point for the original function that we don't have access to its graph yet. Okay, but I want to know which one is this. And let us understand that. So you remember I told you that in the lesson, you just draw this table. You don't need to be very precise. This is the x row. This is the f prime row. This is the f row. Can you tell me what are, according to this picture, because we are supposed to look only here between 0 and 5, what are the nolles stelles of f prime that you can see? Yes? A and B. Which one is the smaller? A. So I write A here and B later. So these are nolles stelles of f prime, so these are 0. Okay? But now, do you remember, I don't know this, because this is f row, I don't have f, so there's nothing I can do here, and I don't need it, you will see. But you need to know if it is positive, negative, or what. Okay, and this is even simpler if you understand what you are doing. You want to see if the derivative is positive or negative before a. So just draw a line here for yourself. Before a, after a. What is happening? Before a, f prime is positive or negative? Why? Because it is above the x-axis. So it is positive. Yes? You see, before this line, the graph of the derivative is above the x-axis. So it means y is positive. Y is f prime. Yes? Between a and b, here and there. Okay, what do you say? Is f prime positive or negative? Positive, because this is the graph between a and b. It is again above the x-axis. So that one is also positive. And after b, what happens? Positive. So none of them are x local minimum or maximum points. This is positive, this is positive, this is positive. So this point is a terrace point. This point is also a terrace point. So how many terrace points are there? 2 terrace points we have. Okay? So these are local minimum points for the derivative, but for the original function, they are not minimum points. They are terrace points. Okay? Okay, but probably you realize that this one is also something important. Okay, can you tell me something about this point? That was a little bit harder one. Okay? So do you agree that the tangent line here is horizontal? Okay, but be careful. What is the tangent? What is the slope of the tangent line? The slope of the tangent line is the derivative of the function. Okay? Derivative of the function that you see. But this is f prime already. So its derivative becomes what? F double prime. Yes? Whenever you want to find the slope of the curve of the function, of the tangent of the function, you have to take the derivative of the function and put the number there. So if I ask you what is the slope, you can see the slope is 0. So the slope is 0. But this is on the one hand, because it is horizontal, the slope is 0. On the other hand, the slope is the derivative of the function whose graph is in front of you, calculated at the x-coordinate. But this is the function that you see in front of you. Its derivative becomes what? The function that you see is itself f prime. The derivative of it becomes f double prime. So this means f double prime of c is equal to 0. Okay, so this means that if this point is c, f double prime of c is equal to 0. But if f double prime of c is equal to 0, this c is what? This c is a candidate for inflection point. Okay, but is it a real inflection point? Yes, because before this point, the function, it is concave down, and after that one, So you know that this is, hopefully you understood. Everyone, do you have any problems understanding why f double prime of c is 0? Is that understandable? Okay, so when f double prime of c is equal to 0, do you remember we had another algorithm in this chapter related to, this is x, this is f double prime, this is f. The candidate for the terrace for the inflection point is c. Yes? F double prime here is 0. But what I want to know what is the derivative, what is the second derivative on this side, positive or negative, and what is the sign of the second derivative on this side? Can you tell me now that? The second derivative here is the first derivative of the graph. The first derivative of the graph tells you if the function is increasing or decreasing. So here, before that, this is going up, and after that, it is going down. So this becomes negative and positive. So indeed, it is a real inflection point. Okay? Understandable or not? This part I agree might be a little bit hard. That is why it's a level question. But it still doesn't mean that you should lose the points. You at most lose 0.5 point. Okay? So yes. So how many points I have? I have 2 terrace points and I have 1 inflection point. But this inflection point is not a terrace point. Yes? Why is not it a terrace point? Why this is not a terrace point but it is an inflection point? Because you see that this function is not a null stelle of this graph. Yes? Okay, so what should I type here? Hopefully you understood this one. But again, what I'm saying is that for this exam, even if you lose 2 points from this question and solve the other parts, you get still an A. Okay? If you don't get all the points from the previous one, still you have to chance a B, but not an E or a failing. Okay, so that's what I'm saying. Be careful about it. I hope that I could record this. I have mixed the numbers. So what should I put here finally? Can you tell me? F has how many local minimum points? 0. Because this is talking about F. How many local maximum points? 0. How many terrace points? 2. And how many inflection points that are not a terrace point? 1. So it becomes 0, 0, 2, and 1. Yes? Anyway, let us go to the next one. The next one, many of you didn't solve. We solved these problems. I mean, this is mainly memory, I would say. If the function f of x equals to this, has an inflection point at this point and a local minimum point on this point, find a plus 2b plus 3c plus 40. Okay? So, what should I do here? Do you remember? This is something you need to remember, or you have to find everything from scratch. It is not possible to do everything from scratch, especially during the stress of time and everything of the exam. Okay, so try to memorize a little bit. So that's why it's very important to organize yourself, to write some notes so that you can read from them quickly. So, do you remember what are the things wanted here? The inflection point is given and the local minimum point is given. Do you remember I told you to how many pieces of information are there if they give you the inflection point? Do you remember? If I is inflection point, you need to remember this inflection point gives you 2 pieces of information. What are those?
F prime of 0.
No, inflection.
F double
F double prime of?
F.
No, be careful. That's why you have to be very precise in mathematics. F double prime of
A.
alpha
Alpha.
is equal to 0. The second one,
F prime of.
there is nothing to f prime for inflection point. Remember, inflection point is a point on the graph. How many times I have repeated this? If you have a point on the graph, the coordinates will satisfy the equation of the graph. So if your function is y equals to f of x, this means that beta is equal to f of alpha. This is 2 pieces of information that I can extract from this. And if I have a local minimum or a local maximum, for example, let us say that m, I don't know, alpha and beta is a local extreme point, okay? How many pieces of information I can extract here? 2 again. But what are they? The second one is the same. You shouldn't doubt about it, because when you say local extreme, it is still on the graph. Okay? But what is else? F prime of alpha is equal to 0. Okay? Either you have to visualize every time, which will take time, or you have to practice. And then I don't know why you didn't use this, because this is very simple. What is the function now? F of x is what? Ax cubed plus bx squared plus d. Okay, so, and then what is the point? The point, inflection point is I, 1 and minus 2. Okay, I will not start because I have it in my memory that for using this information, I need the f double prime. So what do I do first? I go here, calculate f prime. What is f prime? is 3ax squared plus 2bx plus c. I also calculate f double prime, which is 6ax plus 2b. You agree? Okay, now let us use the pieces of information. From this one, I know f double prime of alpha should be 0. What is my alpha here? 1. So it means that if I go to second derivative, replace x with alpha, the answer should be 0. So let us do that. Instead of x, you put alpha. So it becomes 6a plus 2b equals to 0. This is one relation. And usually simplify as much as you can. For example, here I divide everything by 2. So 3a plus b equals to 0, and I put it in the box for the future. But I can do more. What is the other scenario? The other scenario is beta is equal to f of alpha. Okay, so what should I do? I will go to my function, replace x with alpha. The answer is supposed to be beta. So this means that if I replace x with alpha, this becomes a plus b plus c plus d equals to beta. I put it in a box. By the way, it is always easier to start with extreme points and then go to inflection point. But in practically, it is simpler a little bit. Okay, so don't be in hurry. So these questions will bring you some points, definitely. Of course, this is just 1 point. Might be the real question in the exam will have 2 or 3 points. Then I can easily, I would be more comfortable to break the points for you. Okay, but now I have another piece of information. What is that? M0 and 6 is what? Local minimum. Of course, when you say local minimum, it means also local extreme. Yes? So then it gives me 2 pieces of information again. What are they? F prime of alpha is 0. It means that if I go to F prime, replace x with alpha. But what is alpha now? Can you tell me? No, alpha is 0. Okay? So this means that, and then the answer is supposed to be 0 again. So don't get confused. Here, this is always 0. This is always 0. In this case, alpha was x1. In this case, alpha is 0 coincidentally. Okay, so what happens? F prime of 0 is 0. So this means that I go to F prime, replace x with 0. So this becomes 3a 0 to power 2 plus 2b times 0 plus c is equal to 0. And then you see that this is gone, this is gone. Oh, I found my c. C is 0. Okay? And then another piece of information is the second one. Beta is equal to alpha. But again, what is alpha in this problem? 0. What is beta? 6. So I take them and put them where? Into the original function here. So instead of x, I put what? I put 0. So this becomes a times 0 to power 3 plus b times 0 to power 2 plus c times 0 plus d. And instead of beta, I put 6. Okay, everything is gone. D is also found. So it was a very simple problem. C is 0, D is 6. Okay, what should I do? I put these things back here. So what happens? I will have A plus B. C is 0. D is 6. I move 6 to the other side. It becomes minus 8. This is one equation. Another equation is this one. 3A plus B. And everyone knows how to solve this system, yes? So for example, I multiply this by minus sign and add it here. Minus a plus 3a becomes 2a. Minus b and b are gone. This becomes 8. So 8, a becomes what? 4. If a is 4, b is minus 12. Yes, that's it. But the question mark, because this is autocorrection, I am just writing something that the system can correct. But this is the end of the problem, essentially. So the question mark is a plus what? 2b plus 3c plus 4d. A is 4, 2b is minus 24, c is 0, d is 6. Am I right? So the answer becomes what? Okay. Any questions? Okay, good.